Hi, I'm Xinyu, a PhD student from the University of Waterloo. I'm presenting our work, Exploring Interactive Color Palettes for Abstraction-Driven Exploratory Image Colorization. This work is done with my awesome collaborators, Mingyu, Ziqi, Ali, Ryan, and Jian. Well, let's begin with why color matters. Consider this image. What's the story in your mind? Maybe you will think it's about the robot is attacking the human world. But what if I add some pink colors to it? You maybe start to think about if there is any forbidden love between the human and the robot, right? But it seems their love is in a sad end. So the colors are very important. They're the language of our emotions and imagination. Whether we're creating a poster to attract participants in our user study, or creating slides for an in-presentation, or tweaking a photo to match the vibe we are feeling, there's a pretty good chance we will want to play around with colors. What we'll probably do is open Photoshop, import the image, then start a very long day to carefully select regions. In the end, we finally can make some color changes. The good thing is, we have the full control over the image. We can select even the most tiny parts to recolor. But the price is, it can be super time consuming and tedious. We will spend a lot of time on it, especially compared with the exact time we spend on exploring colors. We will be so distracted by the details of region selections that we will lose our bigger picture in our mind about the color combination and their interdependence. Even worse, given a lot of time we have put in, we will not do further explorations for more design possibilities. Such manipulation way, we call it concrete-driven approach. But what if there's another way? Inspired by approaches in other design fields, such as 3D shape design, where interactive visual abstractions have been successfully employed to enhance the creativity and exploration. We asked ourselves, could a similar concept be applied to color design? Can we enable an abstract-driven manipulation approach? This led us to our first research question. What are the potential design choices of visual abstraction for color design? To answer this question, we conduct a formative study with 6 participants with different levels of expertise in design. We arrived at 3 choices. They are existing color palette formats that can be found in many online platforms or literatures. Driven by this, we designed and developed Mondrian as a test bed to validate this idea. It supports a 1D uniform format for basic color value changes. It also supports a 1D proportional palette to allow users to adjust the proportions of the image. And the 2D spatial palette showing the color spatial relationship is also supported to allow users adjust the colors in different regions. Let's see how it works. Starting from an image, we first use the k-means clustering algorithm to extract the dominant colors with their proportions to construct the 1D and 1D plus palettes. For 2D palettes, we first obtain its superpixel segments. Then for each segment, we find its most dominant colors. The Mondrian interface allows users to play with these palettes. With the modified palettes, we feed them to the recolor model to recolorize the image. In specific, for the 1D and 1D plus formats, the histogram of colors is injected into the model as the condition for models to optimize for. And for the 2D palette format, the spatial information of the colors is leveraged by the model. Now, let's use the Mondrian to further understand how users think about this interactive color palette idea. First, we'll ask what benefits and challenges does each abstraction choice present when users interact with them. In the first task of our user study, we'll ask users to try all the 3 palette formats and freely do some explorations with the given images. we found that, in general, users thought the 2D palette is the most intuitive one. This visual information is appreciated because it can help them quickly build association between the colors in the palette and the regions in the image. They also consistently felt the 1D plus palette is more intuitive than the 1D uniform one. Regarding the expressiveness, users find more information encoded in the palette helps, but the extent depended on the characteristics of images. For example, this image doesn't have very clear regions. It's more about the feeling of this landscape. The first two images, the image A and image B there, are recolored with 1D format that the users felt pretty satisfied with. But you can say in the image C, it is recorded with a 2D one. We found that users struggle with the sky area. However, for the image with more clear regions, the 2D palette works better. Here in the left image, the user is trying to create some contrasts between the left and the right with a 1D plus palette. However, they failed to do so because the 1D plus palette is creating a unified color distribution over the entire image instead of some specific regions. But with the 2D palette format, such contrast between the different regions is more easy to achieve. This told us that for interactive visual abstractions, it is very hard to find one-fits-allness. Instead, providing more options for users to choose would be helpful. Regarding the color granularity, we found that for the 1D and the 1D plus formats, some participants prefer a small set of colors, say 5, which is consistent with the current most common color palettes, for example, in the Adobe Color, that is 5. But others, especially people with higher expertise in design, they may prefer more detailed color numbers, say more than 8. But for 2D formats, all users prefer to have more colors in the palette to have a better control. Further, we ask, when taking all these 3 palette formats together as a unified abstraction-driven approach, how does it influence the color design ideation process compared to concrete-driven color editing? In the second task of the user study, we compared Mondrian with a typical concrete-driven approach, Adobe Photoshop. We found that playing with interactive color palettes allows designers to explore color combinations more freely and more creatively without getting bogged down by the details. Photoshop is expected to offer more flexibility and control precision than Mondrian because the abstract-driven approach of Mondrian inherently sacrifices some controlled freedom for the creative support. However, we observed that for novices, they can also be struggled with the rich features in Photoshop. For example, in these 2 images, the users spend a lot of time on this detailed part, trying to make it perfect, but being frustrated in the end. Instead, they appreciate the flexibility provided by Mondrian without much operation burden. This suggests that Mondrian may serve as a more intuitive and user-friendly tool for color design exploration, particularly for novice designers. The research questions we have answered through our user study is more about the interaction side. Besides them, we are also curious about the perception side impacts of the different color palette formats. We ask, how do different abstraction choices affect human perception and understanding of color compositions? We conducted a survey study with 100 participants to further quantitatively measure this question. We have chosen 5 different color combinations and tweaked their corresponding palette formats for testing. By presenting our participants this interface, they are asked to rate the given palette regarding its harmony, valence, and arousal. Here are the statistical results, but don't read this table. The takeaways are: the first, color combinations significantly influence the perception. And second, the palette formats influence the perception with the impact level varying across different color combinations. In specific, the difference between 1D and 2D consistently influenced the perception. In contrast, the influence of 1D plus versus 2D is less consistent. Interested in more detailed findings, please check out our paper.